So yeah, I'm not usually in a wheelchair, everyone, but I got out of bed this morning and things weren't feeling all that great on my back. I get to the hotel an hour ago and boom, barely get out of the car. So I figure I'm gonna need an ambulance to get me out of here either way. We may as well just get the present. So I think like most of you, my job is to live in the future a little bit. I look at display trends about 5 years out and develop a vision for NVIDIA such that our display technologies can intersect these trends. So what I want to do for today's discussion is I want to just first start off by sharing what NVIDIA's vision is of the automotive market in the year 2020. And then I'll talk a little bit about some of the factors that we expect are going to drive this vision and are going to make it become a reality. And then finally, I'll wrap up by talking about some of the challenges and even opportunities that this vision is going to present for most of the people in this room. So when I look at the year 2020, this is what I expect the car to look like, and this is what NVIDIA expects the car to look like. Now, this is a relatively futuristic picture. It's true. But when you look at the displays that we're showing here, most of these are displays that we have in our cars today. Right? Most cars have a navigation display. Some cars are starting to have hybrid, fully digital instrumentation clusters. Most cars have rear seat infotainment and entertainment. But the couple of display classes that we expect to start really ramping up over the next 5 years are displays associated with driver side infotainment. We expect displays associated with controls to start ramping up pretty quickly. And one of the last segments that we expect are going to increase quite a bit are displays that take the place of mirrors, so mirror replacements. Now, these aren't just displays that we have today, the rear view mirrors that we have today, but we have an expectation that side view mirrors are going to start becoming digital displays as well. Now, granted, what I'm showing here is more of a premium sedan, but what's interesting is that we expect this same trend to hold true for pretty much all segments of the automotive industry. So what we expect is we expect entry-level cars, which today have anywhere between 0 to 1 displays, to move up to about 1 to 3 displays. We expect more mid-range cars to go between 1 to 7 displays, and we expect more premium sedans to go from about 7 to 12 displays. So in essence, we're talking about a 3x increase in the volume of displays that are in the car. Now, what gives me a lot of confidence in these numbers is when I talk to OEMs, so when I talk to tier ones about what their vision is, it actually, what they say correlates pretty closely to what I'm showing here. But what gives me the real confidence is when I look at the technologies and when I look at the companies that these OEMs and tier ones are investing in, it really goes to show that they're planning to intersect these trends of more and more displays in the car. Now, I think right now is a really good time to ask, well, what's the factor that's going to cause this, right? What is it that's going to make, what's the catalyst that's going to make OEMs and designers start incorporating more and more displays in the car? But more important, what is the catalyst that's going to make a consumer pay for these accessories? Because this actually comes out to a lot of money. So we think that there's going to be 2 catalysts. The first catalyst that we think is going to change this and make this vision come true is the availability of more and more graphics and computing capability in the car. And the second factor is really, I think, the most important one, and the experience, the experience, the HMI, and the content that we're going to be able to start rendering for these type of displays. So let me first start off by talking a little bit about the graphics and computing capability. So when I talk to a lot of display manufacturers today, whether they be T-Con manufacturers or display manufacturers, I hear something interesting from them. I ask them what their roadmaps look like for resolutions beyond 3840 by 720 and 4K. And a lot of them look at me and they say, well, we don't really know how that's going to fit into our roadmap. And the reason they cite for that is they say, well, we don't really know if an SoC is going to be able to support these resolutions. So the first thing I want to do is I want to completely dispel that right now. Because when you look at one of the products that NVIDIA is releasing, it's called the NVIDIA TX1. This is the automotive SoC that we announced at CES in 2015, and we're going to have it in production in 2016. This particular chip, the TX1, can render and output over 16 million pixels at 60 frames per second. So if you do the math on that, that comes out to about 2 4K displays, 2 3840 by 2160 displays that we're rendering at 60 frames per second. And it doesn't just have to be two 4K displays. It can break these pixels down into any combination that you like, whether they be two 3840 by 720 displays and a third 4K display. So the SoC that's necessary to drive more and more displays at higher resolutions exists today. Just want to make sure everyone understands that. Now, from the computing and graphics perspective, because you need to be able to render content for all these displays, from the computing and graphics perspective, this TX1 is about the size of a thumbnail, and it consumes in the order of less than 10 watts of power. So the graphics and computing capability that this chip has is equivalent to the highest end supercomputer that existed in the world in the year 2000, which took up the size of houses and consumed thousands of watts. So now what we have is we have this intense amount of graphics and computing capability that we can now fit in the car, and we think this is going to be a huge growth motivator for the display segment because of the content that we're going to be able to render for that. Now let's talk about the second and I think most important factor that's going to drive these displays, and that's the content, right? It's the user experience. So to show the kind of changes that are going to be happening in content, what I've done is I've shown the content from a car that was rendered on a lower power SoC, non-NVIDIA SoC, back in 2013 at the bottom. And this content is actually in production on a relatively high-end luxury car today. And I've shown the content that can be generated and rendered in output by the NVIDIA TX1 on top. Now, when you talk to OEMs and Tier 1s and show them this vision of displays in the car, one of the biggest challenges that they're going to describe to you is that they need content for these displays, especially the cluster display, that looks realistic, right? They want the content to look as though real needles are there and real gauges are present in the car. So a couple of the key focus points for NVIDIA is working on rendering content such that it looks 3D, right? Such that it has depth. And that's one of the biggest breakthroughs that I think is going to add value to the consumer experience, that perspective of depth in 3D. Now, second is this technology called material definition language. So what material definition language is this ability for us to create a photorealistic rendition of any natural material and display that in the car. So what I'm showing here in the instrumentation at the top, and I don't know if you can see it very well because of the qualities of the projector, but there's 4 different materials that we've rendered in this HMI at the top. In the back, kind of where it shows black right now, the material that's there, and you see it on a higher quality display, is carbon fiber. Towards the center, that metallic content, that's titanium. Towards the outer range where you're seeing a little bit of gray, that transparent, that's glass. And at the edges, what you're seeing is chrome. So we've rendered this material to look exactly as it would if you had this material sitting in the car. Now, the reason that this excites OEMs and car manufacturers is, well, one, it creates content that's realistic, right? That makes the experience realistic. But 2, what it does is it gives car designers the ability to give a little bit more sophistication to their car. Because what they can do now is they can render content that's used throughout their cabin, right? So imagine having a dashboard that has a fine wood grain trim inside of it. What we can do is we can render that same wood trim into the cluster, into the navigation, in any of the displays that we drive. And essentially what that does is it gives the car and the design a sense of cohesion. It brings all the elements in the car together. And we can do this with any material, whether it be rubber, whether it be ceramic, whether it be stitched leather, anything. So the content that we can start rendering actually looks realistic. And in terms of realisticness, another big focus is being able to render properly light and being able to render shadows. So you need to be able to show light properly as it scatters through the glass that we've shown in this cluster HMI. You need to be able to show it properly as it reflects off the metal. You need to be able to render shadows properly. So it's this type of attention to detail that we think is going to add to that consumer experience and really make them want these displays and this content in their car. Now, when I look at most cars today, I think one of the things that disappoints me the most is the color gamut and the color depth that these displays have, the content on these displays have. And you can kind of see this if you look at the HMI on the bottom, right? You can see how low the color depth is, especially if you start looking at the shadows on the top and the shadows at the bottom. But I think what's probably the most offensive is how low the color gamut is, right? You can see that the red isn't really red, it's a very dull red. Now, in this world where we're talking about creating content that looks realistic, you can't really do that if you have really low color gamut displays, right? It doesn't matter how great the quality of the content that we're rendering is if you don't have colors that look lifelike. So for all of you display manufacturers in this room, I want to really emphasize the need for having high color gamut on your displays and high color depth. And this is going to become especially important when you start hearing about high dynamic range content, which OEMs are going to start talking to you about in the next couple of years. It's going to be a really big topic for them. So focus on color gamut, focus on color depth. Okay, so moving beyond just content for the cluster and content for navigation is safety content. And this is going to be a huge driver in the automotive space. So for those of you who are familiar with the type of sensors that are used in the modern day car, there's sensors everywhere. You have cameras, you have radar, you have a LiDAR, and all these sensors and cameras are really necessary when you start thinking about autonomous driving, right? You need these sensors to be able to guide the car through its path. But now think about the amount of value that you can add to the car if you were to take this sensor data and do something with it for the display. So a couple minutes ago, I talked to you about the value that I think is going to come out when you start replacing side view mirrors with displays. Well, one example that I want you to consider is if you're driving at night on a poorly lit freeway, and you have a motorcycle next to you that might not be as clear, they might not be able to see as well. What the cameras can do is they can show the content, right? They can just show the motorcycle. But with the amount of computing capability that we have, what we can do is we can actually start highlighting that motorcycle in your display, in your side view mirror display. So instead of just seeing what looks like a motorcycle, we can highlight that there's a motorcycle there, be careful of it. So we think this safety content is going to be one of the biggest drivers for more and more displays in the car. Now, this vision that I've put in front of you, next slide please. Now this vision that I've put in front of you, it's relatively rosy, right? And if this vision comes to fruition, or when this vision comes to fruition, it's going to be a boon for everyone in this room. It's going to be a boon for SoC manufacturers, for TCON manufacturers, for display manufacturers. But realistically, there's a lot of challenges in the ecosystem that we have to resolve before we get there, before we can actually make this vision a reality. And this is one of the other major aspects that NVIDIA focuses on. There's challenges associated with bandwidth. We talked about that a couple minutes ago when I told you about the resolutions that the SoC can render today. But beyond just the SoC, there's limitations in TCONs and the bandwidth that they have for receiving data. There's limitations in the display link between the SoC and the display. Power is going to be a huge ecosystem challenge. Right now, imagine that you have 12 displays in your car on a hot summer day, and each of those 12 displays is outputting full blast, somewhere about 10 watts of power. That's the equivalent of having a 120 watt light bulb sitting in the middle of your cabin. That becomes really uncomfortable. So NVIDIA is working on a lot of technologies that help us reduce the overall power of the system. Visual performance, another huge one, right? If you look at the temperature variations in the car, being able to make a display look fantastic, whether it's running at room temperature, or make it look fantastic whether it's running at 100 C or negative 30 C, that's really difficult. So one of the other challenges that we're working on is being able to improve that display quality at these extreme temperature ranges. Of course, there's limitations with cost, with reliability, and with interface. Now, I can't go through all these challenges with you in this format. I wish I could. But I think probably the biggest challenge that I want to take a moment to talk about is the challenge associated with interface. So if you were to show this vision to most tier ones, most OEMs, they'll look at this and they'll say, yeah, this is generally correct. We expect this to come true. But one of the biggest challenges they're going to highlight for you is how are we going to cable this? How are you going to design a car harness that's going to be able to connect to all these displays and actually connect 12 displays to the back of an SoC, right, to the back of a computing box in your car, or maybe a back of 2 or 3 computing boxes. It's really difficult. And the reason that that's a challenge is because of the way cabling is done today in cars. Next slide, please. Okay, so if you look at the way cabling is done in cars today, it's done with something called SerDes. These are serializers and deserializers. So just to give everyone a quick understanding of how this works for those that aren't familiar, what happens is the SoC outputs a data stream, whether it be LVDS or HDMI, and this goes directly into serializer, which is an inch away or so. This converts that LVDS stream into a differential pair that's proprietary. It gets transmitted along the body of the car, or in some cases only a foot, which goes to a deserializer, which reconverts that back into LVDS, and then it drives the display. Now, this is really challenging because you have to have these serializer and deserializer combinations for every display that's in the car. This is how modern cars are built today. And this is really challenging because, well, one, the bandwidth, the cost, right? Each of these serializer, deserializer pairs today cost somewhere upwards of $10 a pair. And that's going to get worse and worse as we start talking about higher resolutions and higher bandwidths. Two is there's a lot of reliability concerns with this, right? Each of these SerDes pairs presents yet another point of reliability, yet another point of failure. There's issues with increased power consumption, and I think probably the worst issue is that these SerDes are based on proprietary technology. So unless you are the SerDes manufacturer, there's no innovation there. So what NVIDIA's vision is, and what we're trying to drive in the display market, is the transition to DisplayPort. This is the same interface that most of you are familiar with is used in the consumer space. We're trying to drive the same interface to be used in the automotive space. And there's a lot of reasons why we think that works. One is it's an open standard. Anyone can innovate, anyone can contribute to it. Two is it's much lower cost. Now you can have a point-to-point connection from the SoC to the display without having a serializer or deserializer combination between it. So it drastically reduces the cost. Three, less potential points of failure. It's lower power, and it's simpler cabling, especially if you start using technology such as multi-streaming. You don't have to have point-to-point. You can have a network of displays, and that makes the cabling much, much more efficient. So my time is pretty much up. So what I want to do is just summarize a couple points that I made here. Okay, so the couple things that I want everyone in this room to take away. If you look at an automotive SoC, today it can render very, very high resolutions, even beyond 4K. And it can do it at very high frame rates, 60 frames per second, which is critical to all OEMs and tier ones. Two, if you're a display manufacturer, focus on resolution. Resolution's good, right? But more important, focus on color depth, focus on color gamut. This is what's going to allow you to differentiate from your competitors. It's critical, especially when we start thinking about high dynamic range. And three, if you're a TCON manufacturer, receiver manufacturer of any type, make sure that you have DisplayPort on your automotive roadmap. This is going to become critical, and you're going to have OEMs start asking for this very soon. There's a lot of other innovations and opportunities that I can tell you about, but unfortunately I can't talk about them here. So please, here's my contact information for those of you who want to learn more, want to partner with NVIDIA. Feel free to reach out to me, and we'll do whatever we can to work with you. Thanks a lot. Have a good evening.